Hi everyone. Today we have Matthew and Ryder, and they're gonna talk about their project in the software engineering class. The project about the money currency scanner, and what is the thing to talk about. Go.
Yeah, this is our project from last semester of software engineering class. We decided to make an app for scanning money for visually impaired. That way they can mainly dollar bills because you can't differentiate from a $1 bill, a $5 bill without looking at it. So we made an app that you can download on your phone to just scan a dollar bill.
So what you said.
We made it available for iOS and Android. It's not, you can't go download it, but it's works on both.
So this is our design we came up with. We wanted it to be simple but also look nice on the phone. So look for a nice black color scheme, and we made it have some green tints to it, so it visualizes like money. But our main focus was making it able to have a list view, and then also the amount being scanned and the percentage accuracy. So on the
So the middle view is the home page. So when you first open the app, that's what you'll be displayed. It'll show your camera, and then at the bottom, what you're scanning. And then on the left is the history page with all your previous scans. It has the amount added at the top of just the sum of all your scans. And then you can clear one at a time or delete them all at the same time. And then on the right is the settings page. We don't have too many settings that you can change, but that was just a concept of settings that you could add to change features within the app.
So for creating the app, we used a language called Flutter, and it's from Google. It's a mobile app development language that allows for cross-platform use. So we would get it on iOS and Android, and it's optimized for the UI, and it has integration with machine learning. And it's pretty similar to CSS and JavaScript and the way it's set up. And it's just easy to integrate with what we were wanting to do.
Yeah, and then in order to integrate the detecting of money with in the app itself, we used Tensorflow. It's a machine learning platform where we could upload. To create it, we uploaded first found images of money. We just downloaded them from Google Images. We could just search, for example, like a $1 bill, and just downloaded every image. We had to manually go through, delete all the images that either weren't $1 bills or just all the other stuff that Google that got downloaded from Google that we didn't want. And then we were able to use Python to just make these images all uniform size. We had to make them all square, so that way there wasn't stuff cut off from the images when we would do what we would do with it later on. So then once we had all the images and then all, uniform, we could then go ahead and put it into our model. And with this model, we didn't have to do much. This model would do most of the work on itself. We just have to set it up, and then with all the images, it would run, just specifying which images were which, and then it would run and give us an output of being able to detect. And just a little bit about just the algorithm that goes into detecting an image. It would first scan through all the pixels of the images, getting the colors that were there, and it would assign a value to each location on the images based on what color that pixel was and the colors of pixels around that, and then it would compare that to the image scanned based on that data to find out if there was an image or not. And then integrating the model that's outputted with our app, we were able to just upload that into our app with the app's camera, and we can use the camera on your phone to get that image and then run that through the model that we had.
Yeah, so some other apps similar to what we have or what we made are LookTel and Cash Reader Bill Identifier. All these are good apps. They didn't have the features that could be used for like telling you the amount with voice feedback and actually recognizing the bill. So we decided to fix that, and this is what we came up with.
Yeah, if you can see by this picture over here, it looks kind of old and not very up to date. Not that that has any functionality of detecting the bills, but just kind of other just improvements that can be made with the app and just make it easier to use. So now we'll just give a little demo about where they're at.
Voiceover on. $ scan. Scanning. $50.
So when you first open the app, this is what you'll see. If it doesn't recognize anything,
$2.
it'll have the scanning at the bottom. Otherwise, it'll hopefully get the right amount.
Scanner. $50. $2.
So part of the why it's not recognizing it is because the amount of images that we had a couple hundred for each denomination.
$50.
So if we had more images being able to recognize them, it would make it more accurate.
$2.
And for the $2, it's saying that a lot
$50.
because we had the least amount of images of that. And just getting rid of the $2 would probably make it a lot more accurate.
Amount.
Yeah, but it does
$50 USD.
it does show the amounts it had scanned. So it has the list view available and your total amount that was scanned.
And then for, you can see there's a lot of the same, but it won't allow you to, if you scan the same bill multiple times and it recognizes it, per se it's a 5, then it'll only add it to the list once. It won't continuously add it just because it's a 5. It'll know that you're still scanning the same bill.
Yeah.
And then if you were to close the app and reopen it, it'll keep all your scans and have it just store it locally on your phone.
Could you guys read this thing? It was working.
Amount. 50. Scanner. Scanner.
There it goes.
You want me to make it closer?
Yeah, so now that you know that the one.
Scanner. History. History. Amount. $50. App switcher. Voiceover off.
So if we scroll down here, we can see that it scans the $1 bill right there. So yeah. And just for, so here's our main code that we wrote. And so basically this is just for the home screen, it's loading a camera and making sure your device has a camera first. So you need that to scan. So once it got that, it will be able to start the recognition process, which is this line of code right here. It's getting the height and width of the image and comparing it to the images that we had in our model.
And on getting the images, the camera it records just continuously, but it only takes a picture every 2 seconds, and that's the image that it gets run through the model is one every 2 seconds. And then for I guess styling the app itself, it's a lot like kind of like a combination of HTML and CSS and JavaScript all in one. That has some of like the same properties as CSS. You can specify all the padding, margins, different colors, different sizing, and all that kind of stuff. And then it's an object-oriented language, so everything is class-based. And it's called stateful. It's built on widgets, is what it's called, for all the each feature, I guess. So there's stateful widgets and stateless widgets. The stateful widgets are things that can change. So like the history page with all the different scans, what's being scanned, and then there's stateless widgets, which are just constant throughout the duration of using the app. So like the camera and things like that.
Yeah, and then probably,
And then I guess we can look at the storage.
yeah,
Um,
for storage.
It just stores it in a text file on your device. And then just every time you scan something, it adds a line to that text file of what was scanned, and all the information that goes along with that. And then on the history page, it'll read that file and then output what's in that file onto the page itself. And that links just all of the pages together is this storage file, and then it'll keep this file when you close and reopen the app.
Yeah, so yeah, that's what it is.
I guess does anyone have any questions?
Question.
What machine learning algorithm did you use?
I don't know the specific name.
I think you said things like flow.
Yeah. Yeah, with deep learning.
What do you see as the purpose of the history storage?
I mean, just so if anyone ever, if you wanted to see your history, I mean, like just how much you've been scanning or like saving it like a piggy bank, basically.
Yeah, mainly for if you were counting more than one at a time, or trying to be more than one at a time, and not just one bill.
So could you like have a table of bills and the app read each one individually, or is it just one at a time?
Yeah, you have to do one at a time.
Yeah,
They can't. You just can't lay out like 5 bills and get them all scanned. That has to be one at a time.
Could you perhaps alter your code in a way to do that? Would it be difficult?
Yeah, we could do that. It would be just using post processing with like taking a picture basically and then scanning the picture itself. But
Instead of just recognizing that there was one bill, we'd have to recognize them being multiple. But we could just, if we could recognize that, then we could just run those individual ones through them.
So I look here, the thing of correct answers. Is it easy to modify the code that you could have people using the app and then verifying that it was either right or wrong or anything what actually is? We had a non-visually impaired friend that would help you like get accuracy coding. Is that something that happened?
No. Yeah, I guess just confirming that what was scanned was correct, and just basically adding those images to the database of images that we had.
But you can do that just like over the mobile networks and things.
I don't know that we could update the model.
we don't have any current cloud.
Yeah, it's not. It's just all locally on the phone. So we couldn't do that now. But just saving those images into our database of images and then running those with our model.
So how many total images does the app go through to recognize what bill it is?
For each bill, I think in our model we had a couple hundred for each. And yeah, upping the amount of images would certainly make it more accurate. But just going through Google, instead of taking images ourselves, we just went through Google Images and found images. So we could only get what they had.
Yeah.
How is your accuracy measured?
Just the accuracy that's displayed on the app itself. That's with our model. The model outputs how accurate it sees that bill. And there's not just one, there's multiple, I guess, accuracies for every bill. So in one scan, it might say it thinks that it's a $5 bill, 60% confidence in a $5 bill. Maybe for like a $10 bill, it thinks it's 10% confident that it's that. So it's not just, it thinks this is one bill and that's it. It kind of is a range of all the bills, and we just look at the top bill to, I guess, pick which one it thinks it is.
So you compile that to the computer in terms of the measure of accuracy? Just what
That's kind of just what the model gives.
image comparison software is?
Yeah. But you're able to set like a threshold level to set your accuracy.
So yeah, our app, if it wasn't over 80% confident that that was the bill, then it just wouldn't display that it recognized anything.
How about coins? We think of adding coins.
We tried that, but
Coins were a little
nickels and quarters are so similar. At least looking size is, I guess, one of the big things, but you can't really see that on an image. So it definitely struggled deciphering things.
One more question. For the machine learning algorithm, if you add more images, the accuracy will be involved. Does it work like add when you scan the bill? Does it add it to the images, save and retrain the model again, or not?
not at this time, but that's something we can look into.
Yeah, that would definitely make
Yeah.
it more accurate, just so we have more images to look through.
But then it's all locally on the device, that would be a lot of space taken up.
So does that mean like all the pictures that you have would be stored also on the device, or would that be?
Well, if it was optimized, I guess those pictures that were scanned would go to like the cloud, and through that we would use those pictures to retrain our model, and then hopefully put the model back onto your app locally.
Originally, we will need the images to be stored because the deep learning algorithm will take train the model and every time just use the training model. So maybe you could be uploaded in the cloud and every time we need to update with the new gas or the. And what do you think, guys, like, how to improve your app?
Definitely the accuracy would probably be the number one thing, because it's not that great. And just, I'd say maybe just deleting the $2 bill would certainly help a lot.
Yeah.
And then just getting more images for the other bills.
And then some post-processing things that can be done with the camera. So taking a picture of it instead of recording, then you can get depth information from the camera and then look at the bill itself or the coin and find certain details within that using fit mapping. So
Is there a tool that I never saw it? I never seen it before. Is there like a tool that
yes, yeah.
Yeah, we probably shouldn't have put that in because there wasn't very many good images of them. So we probably should have just left that out from the start. So.